This is what we're trying to solve. And don't forget, for any kind of equation, what solve means is find the value or values of x that when we substitute it in, it makes the two sides equal. That's what solve means. We want to know is what are those values of x? When I put them in there, they're going to work. What is all this stuff at the end? It is a little scary stuff. Yeah, you've seen this before. It means between. It means 0 can be between 0, or angle can be between 0 and 2 pi. The reason they're limiting you is because we know because of coterminal angles, there could be infinite amount of answers. So they're limiting you just to one revolution of the circle. What that does is makes finite amount of answers. So going from a possible amount of answers, they're going down to 2 or 3 different answers depending on the question. Again, I'm going to show you method 1. If you like it, then completely ignore method 2. If you hate it, then come over to do method 2. You don't need to know both. You get to pick and choose which either one you like better. Method number 1 I call left-hand side, right-hand side. Left-hand side, right-hand side. Method 2 I call it all on one side. So let me flip to my calculator. Yes, it's pink on here too. I'm going to go into my y equals. If you've got anything in there, just clear it out. So hit the clear button to get rid of anything you have in there. What we're going to do is we're going to put the left-hand side of the equation into y1, and then we're going to jump down and we're going to put in the right-hand side of the equation into y2. What that's going to do is our calculator is going to graph 2 different lines. It's going to show you the right-hand side and it's going to show you the left-hand side. To solve it, we just need to find where those lines intersect. But because this is a trig equation versus the parabolas or absolute value or radicals you did last year, there's something special with trig values. And what I need you to do is press your mode button, which is right beside your second function. And remember grade 10, we were like degrees, degrees, degrees. Calculator must be in degrees. Well, guess what now? You have a choice. So how do you know what you need to be in? Look at the question and look how the interval is given. If the interval is given in radians, you need to give your answer in radians. If the interval is given in degrees, you need to give your answer in degrees. Because it says 0 to 2 pi, what does that tell you? You need to be in radians. So you just move the arrows down to you're on top of the word radian, you hit enter, and it should turn black, and the degrees stays white. This step didn't matter last year. Now it does when you're doing trig equations. Once the radian word is black, you can just second function quit out of there and go back into your y equals. So the left-hand side, I'm going to type exactly what we see, which is 5x, so 5 sine x. Okay, so whatever's on the left-hand side goes into y1. I'm going to arrow down to hit to y2. And I'm going to put in the right-hand side, which is 3 cos x minus 1. Now, my calculator is in the old operating system. If you just bought a new one, it will be in the new operating system. So it may have opened that bracket in front of cos. Mine did, but it didn't close it. So just depending, yours might not look exactly like this. Are we all good so far? Then we hit zoom, just like last year. Now, last year we were like zoom standard, zoom standard, zoom standard. Everything we did was zoom standard, because standard is negative 10 to 10. That's out for trig functions. What we want to pick is zoom trig, because what that's going to do is put our axes into radians. So I'm just going to hit number 7, and you should see 2 funky graphs appear. If your mode is in degrees, it will not look like that. If you hit zoom standard instead of zoom trig, it will not look like that. That's what yours should look like. Let's just back up. What do parabolas look like? Show me with your fingers or your hands. What do parabolas look like? We call them the U. Do you remember absolute values from last year? They were the V. So show me a V with your hands or fingers, whatever you want. That's an absolute value. We did linear functions in grade 10. What do linear functions look like? They're a line. Do you remember radical functions? That was the end of last year. Radical functions are the swoop. So it swoops like this. All we're doing now is adding trig functions. We're going to come back to the shape of this graph in Unit 3, but all you need to know is like a heartbeat. It goes up and down and up and down. Who's done physics? Have you done light waves and sound waves? Those are all trig functions. That's all where it comes from. They're light waves and sound waves. Questions so far? Now all we need to do is find the points of intersection. So if I go left or right, there's a point of intersection up here. There's one down here. There's one just past the y-axis, and there's one down here. So from 0 to 2 pi, how many times does it intersect? Well, what you need to know is when you asked your calculator to do zoom trig, it has given you from negative 2 pi to positive 2 pi. So for our questions, all you need to look at is the right-hand side of the graph. This is all we're concerned about. I don't care about what's happening over here. So from 0 to 2 pi, how many answers are we going to have? 2. I've got one up here that crosses and one down here. I'm going to ask the calculator to tell me what those values are. I'm going to go second function calc, intersect, and the cursor is probably on the origin. I call it the little spider because it looks like a spider with legs. All I'm going to do is hit enter once, enter twice, enter a third time. Second function calc, number 5, enter, enter, enter. Second calc, intersect, enter, enter, enter. Again, if you're lost, it's nice in this box right here. It's right there. Again, this is not new. You did this last year, so if I'm going too fast, come in tomorrow morning. We can fix it. So to show the work for this question, the first thing I'm going to do is just sketch what the graph looks like in this box. It doesn't need to be perfect. I'm just doing a little sketch. You can do everything you see, or you can just do the right-hand side. It's completely up to you, because the left-hand side for us is not important at this point. So I'm going to draw the axes in the middle, but I'm actually not going to draw anything on the left, just because I don't want to confuse anyone. So I'm just drawing briefly what I see on the right. There's a graph that comes down like this. There's a graph that goes up and kind of comes down and goes up. It's a sketch. It doesn't need to be exact. It doesn't need to be perfect. It's just a sketch of what you see. Again, you can draw what's on the left. It's just irrelevant in terms of what we're doing, so you don't need to draw it if you don't want to. So step 1 to showing the work is just sketching the graph. Step 2 is marking the points we're finding. We just found the first intersection, and we're going to find the second one in a second. That's step 2 is showing the work. Draw the graph, mark the points that you found. Step 3 is writing down the answers. We only care about the x values. Y is irrelevant, and I'll tell you why later. All you care is about the x values. And there's usually rounding instructions in the question. So look back at the question. What does it say about the rounding? 3 decimal places, so we're going to round this first x value to 0.368. I don't care about y. I'll care about him later. I don't care about him right now. But I still need to find the second intersection point that's down here. So I'm going to repeat the process. I want you to watch me and then do it. Don't try to do it at the same time. I'm going to go back to second function calc. I'm going to go back to number 5. Look where the cursor is. It should be flashing on that first intersection point. To tell the calculator I want to find the other one, all I need to do is move closer to it. I'm just going to hit my arrow till I'm somewhere closer to this other intersection point. If you stay on the first one, it's going to give you the first one back. The calculator knows which one you want to find just by which one you're closer to. Then I'm going to hit enter, 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 but I'll wait for you to catch up. So second function calc, number 5. Move the cursor till you're somewhere around that other intersection point. It doesn't have to be on it. It just needs to be close to it. It can. It's just why be that exact when you don't need to be? Enter once, enter twice, enter 3 times. Bam, we're done. What's the other intersection point to? 3 decimal places. I heard an offer of 3.854. That is the complete work you need to show me when you solve a question with your calculator. You need to have the graph, you need to have the intersection points marked, and you need to have the answers rounded correctly. If you just gave me the answers, that's 1 mark out of 3, because this is showing me what you did. How are we doing? How many people, and it's usually visual people, when you looked at this graph, your brain went WTH, what the heck? Okay, so if your eyes were like, what is going on, you will probably like method 2 better, because there's going to be a lot less lines. Okay, so let's go to method number 2. I'm going to go back into my y equals, and I'm going to clear this stuff out. So I'm just hitting clear to get rid of it. Method number 2 is moving everything to one side of the equation. So you would check your mode, which we've already done. Now I want to move everything to one side. So I want to take this 3 cos over, and I want to take this minus 1 over. So there's a little bit of algebra you need to do first. I'm going to leave the 5 sine theta or sine x where he is. How do I move this 3 cos over? Right now I'm adding it, so the opposite of adding is. So I'm going to subtract it off each side. And how do I get rid of a subtraction of 1 or a negative 1? I'm going to add. Okay? That's for method 2, is you have to do a little bit of algebra to start with. All I did was make one side equal to 0. And what I'm going to do is put that all into y1. So I'm not going to touch y2 this time. I'm going to put everything into y1. So 5 sine x minus 3 cos x plus 1. Just like before, I want to see the graph, so I'm going to go to zoom. And we brainwashed you into zoom standard last year. That's now out. We want to pick zoom trig because it's a trig equation. Oh, look, that's way prettier. Way less lines going on. The last one you had 2 graphs because we used y1 and y2. This one you've got 1 graph because we used y1. Again, let's just sketch out what we see. You can sketch everything, or you can just do that right-hand side. Completely up to you. If, again, with the first one, your brain was like, whoa, you might like this better because there's just less stuff going on to see. The first method, when there were 2 lines, we found the intersection points. When there is 1 graph, we are going to find the x-intercepts. What's the definition of an x-intercept? We talked about this a lot last year. Point where the graph crosses the x-axis. So I have 1 x-intercept here, and I have 1 over here. Again, ignoring the left-hand side because it doesn't matter for us right now. This is the part, if you've never seen a calculator, you're going to be like, what is she doing? Slow down. I don't have a lot of time to slow down, so I'm going to go through it. If you need to repeat it, rewatch me tonight. If you need help tomorrow morning, she is there because we did all this last year. But if this is new, this is confusing at the beginning. To find x-intercepts, you go second function calc, just like we did in the first method. But instead of picking intersect, I'm picking 0, number 2. And I'm going to find the first x-intercept, which is this guy right here. As long as my cursor is on the left of that x-intercept, I'm going to hit enter. And now the calculator is asking me, tell me a point that's on the right. So I'm going to move my cursor until I'm somewhere on the right of that x-intercept. What that means is above the graph. And I'm going to hit enter. And it's actually put 2 little arrows here, and the calculator is asking me, is this the one you want to find between these arrows? Because it is, we hit enter a 3rd time. So we call that left bound, right bound, enter. You pick a point on the left, tell the calculator. Pick a point on the right, tell the calculator. Hit enter. What's the first x-intercept? X equals 0.3. Well, whoa, that's the same answer as last time. How are they the same? Because it's the same equation, we're just doing 2 different methods. I'm going to repeat the process to get the other x-intercept. Second function calc. Second function calc. Number 2. Now I want to find this one over here. So the left is somewhere above it. Where are you, cursor? There you are. Somewhere above it is the point that's on the left. Hit enter. Somewhere below it is a point on the right. Hit enter. Arrows are pointing. Is this the one you want me to find? If the answer is yes, Hit enter. No surprise, what's the second x-intercept? Method 1, method 2. I don't care, pick whichever one you like better. Show me your thumb. Oh, that's not as many downs as I thought. Okay, let's go to example number 2. Yes. We have to pick a method so we're all doing it the same way. You want to do method 1 for this one, method 2 for the next one? We'll do method 1 for this one, method 2 for the other one. Method 1 is going into your y equals, clearing out all the crap. Again, I call this one left-hand side, right-hand side because we're splitting the two sides. The left-hand side is going to go into y1, right-hand side into y3. Now, if you have the old operating system, you need to be careful how you put in this squared. So if you have the old system, you're going to follow with me. I'm going to put the 3. I'm going to open a bracket. I'm going to put sine x. I'm going to close the bracket twice, which seems weird. And then I'm going to hit my squared. Probably this way, except you may not get the little squared. You may just get the notation for exponent. And then I'm going to add the rest of that left-hand side, which was plus sine. And then I'll just back up so you can see the squared part again. So you might want to just write down how we type that in so that later when you look back, you know how to type in a squared with a sine function or a cos function. Or wait till we get tan and secant and cosecant. Going down to my y2, I'm going to put in the right-hand side of the equation. Within this one is just 3. Just a little old 3. How do I get the calculator to show me the graph? I go to zoom. I go to zoom. And I pick 7. Here's the left-hand side. How funky is that? Look at that. Of course, if that's a heartbeat, the person is probably dying. But that's a different point. Step number 1, sketch the graph. You can do the whole graph or you can just do the left-hand side. It's completely up to you. Just draw a rough shape of what you see. Point number 2, we've got to mark or step number 2, we're going to mark the points we need to find. In this case, I'm doing the intersection point, so it's where those two graphs cross. To find the intersection points, it's second function calc. Number 5. The first one doesn't really matter because it usually throws the cursor on the origin, so usually the first one you can just go enter, enter, enter. You don't usually need to move until the second one. Give me the 3 decimal places. That's the offer, 1.011. Confirm. Now I'm just going to repeat the process, second function calc, intersect. This is where I typically need to move because what's happened right now is it's plunked the cursor on the first one. If you just go enter, 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 it's going to keep giving you back the first one. I just need to move somewhere closer to the other one. Nope, left, right doesn't matter in this one. If you're on top of it, doesn't matter. You just need to be closer. Now it's a triple enter. Bam, 3 decimal places. 2 point. That is what you need to show me to get full marks. The graph is a point, marking the points is a point, and giving the answers to the correct decimal places is a point. If you just give me this, you're getting 1 out of 3. This is the showing the work when you're doing graphically. Then there's this part B stuff. Would you like to shout out or highlight or tell me maybe a key word that we've seen before or a key phrase that we've seen before? Oh, and more than just solution? General, where did we see that before? Who can remember where we saw that before? Coterminal, high five, coterminal angles. That's what the question is really asking for. It's saying, give me all the possible coterminal angles to the 2 answers you just found. Give me all the possible coterminal angles to the 2 answers you just found. Here's how we write the general solution for any trig equation. I'm going to start by listing the first 2 answers we found, 1.011, comma 2.131. Then I'm going to say, well, let's add on some revolutions, and we know a revolution is 2 pi. But I want to add 1 revolution and 2 revolutions and 3 revolutions and all the way up to infinity, so this is where we pick a variable. We chose k for no reason. And then anytime you put a variable in, we have to define it. So this is where we talked about the number families, and we want k to be 1, 2, 3, 4, and -1, -2, -3, -4, all the way up to positive infinity and negative infinity. And what kind of number families are all the numbers with positives and negatives? K is an element of Z, which stands for integers. If you didn't get anything I just said, just know this is what you add on for the general solution. Just memorize it if it doesn't make sense to you. Let's do number 3, and we'll do it the other method just to switch it up. Ooh, this is a little teeny tiny one. Oh, why am I doing that one? Grab my big one. Go into y equals, clear out the crap. I don't need any of you in here. Clear. Method number 2 I call all on one side, so it means one side of your equation needs to be 0. Take a look at the example. What do you see? It already is, so we're just slapping in the left-hand side. Cos 2x, sorry.
So we don't put in cos 2x minus 0?
You could, and you'll see graphically it's not going to change anything. It's going to give you the exact same question. Do you want me to do it just to prove it? Watch, then you'll find out I lied. I think I put a negative, not a subtraction.
-0.
-0. How do I get the graph? How do I get the calculator to show me what it looks like?
By pressing the graph button.
No! I don't want to go right to graph button. I want to go to zoom and then 7. Graph takes the last set of axes, and so I want them to get into the habit of always doing zoom trig, because once we get into parabolas and trig, and then they're always going back and forth, so they could, if they hit graph, it would give them the same thing. I just like this habit. Look at this heartbeat. That's a little bit better than our last patient. Andrew.
Yeah, my calculator.
You got funky stuff going on?
It put an extra thing on each side.
Ooh, why did it do that? And you asked it for zoom trig?
Zoom 7.
Oh, I don't know why. Can you remind me tomorrow morning, and I'll take a look at your settings and see if you've got one different?
This appears to be newer, though.
Yeah, well, I'll play with it tomorrow. Is that okay? We got to mark the points. I got an intercept here, intercept here, intercept here. Oh my God, there's a lot of them. Intercept here. How many different answers are we going to have for this particular equation?
Lots.
4 of them. Okay, calc, let's do the work for me. Second calc. I'm not putting intersect this time. What am I picking? 0. I need to be on the left of this one, which I currently am. I now need to come down and be on the right. Okay, so just somewhere underneath that little section. Check your arrows. They're like, hey, is this the one? Enter. 3 decimal places. Offer of 0.785. Confirmed. Let's go on to the next one, second function calc. 0 again. Somewhere on the left of this guy, so down underneath the graph somewhere. Right is up above. Arrows are pointing, hey, how about me? Enter. Offer.
2.356.
Offer of 2.356. Go ahead and find the remaining 2. Part B. What's it asking for? General solutions. I'm going to grab those 4, put them just in a row. Oop. And then I'm going to add. Now listen. To a mathematician, these are very particular letters in a very particular order. You can't mix them up and think I'm not going to notice. You can't put Z pi KE2. No, it doesn't work that way. It has to be exactly this. Even if you don't understand why, you need to memorize it in that order. These are very particular math symbols. So this is not just random 2's and k's and pi's. 2 pi k, bracket, bracket, E, Z. You'll notice the plus sign is here. There is not a plus sign here. That's like me taking your first name and just rearranging one of the letters. Right? It doesn't work that way. It doesn't work that way in math either. There's where the plus is. No plus over here. How are we doing so far?
Define it at the top if you're doing multiple, like say if on the test there was a 3 in a row, use at the top of all those loops, use like K equals 5 is an element of.
Yeah, I would probably write it just in case the person marking your exam didn't happen to look up, just to be sure. But yes, mathematically you could. Okay, take a look up here at example number 1. Okay, remember we had this interval notation? And look down here. And look down here. What do you not see here?
Interval notation.
No interval. So I'm going to show you what that means after. I just want you right now to pick a method, solve it, get me the values for x. Pick whatever method you like better. Get me the values for x, then I'll tell you what that means. It does not. Good catch.